Hello and welcome to another video on chemistry. I am Preetinder Kaur for Perfect Scores, and the topic of this video is the different types of chemical changes. Now, chemical changes, as mentioned in the previous videos, are of two types. Either the reactions, which are basically chemical changes, can be exothermic or they can be endothermic. So let's have a look at the difference between them. So exothermic reactions are those in which the energy released in the formation of the new structure exceeds the total energy of the reactant substances. That means the energy is given out. It can either be in the form of light or it can be in the form of heat. So basically, the net result is that energy is given out during the reaction. Usually it's in the form of heat or light or both of them. The other one is known as an endothermic reaction. In this case, the new structure actually absorbs energy. So that means the total energy of the reactants was more, or it exceeded the energy that was created in formation. Or in other words, energy is absorbed. That's why it's called endothermic, because the energy is given inside. So now let's have a look at how the activation energy of the exothermic and endothermic reactions looks like. So these are our two graphs. One is for exothermic, and we have the reaction time and we have the energy, and the other one is endothermic with the reaction time and the energy. In case of exothermic reactants, so this is the energy of the reactants. Okay, this is the forward activation energy. Now this gap over here, this one is the forward activation energy to take the reaction in the forward direction. Forward activation energy. After that, the energy needed to start the reaction, it actually decreases as the reaction time goes forward. So that's why the energy of the products is at a lower level. And this difference over here is the exothermic energy. Which is represented by delta H. So let me highlight that little over here. So this is the exothermic energy, delta H, if you make this kind of a graph. Now let's come to endothermic reactions. In this case, the graph starts at a lower position for the reactants. This is the forward activation energy, and this is the energy that the products will have. So the forward activation energy in this case is the whole difference. So this is the forward activation energy. You should be well versed with these graphs because you can have them in the exam, and you may be given a graph and you have to identify what kind of a reaction it is. Forward activation energy, and this gap that exists, this gap is the endothermic energy. again represented by delta H. So we've already done a video on enthalpy, and you know that change in heat content is what this delta H is. So delta H is basically change in the amount of heat, and heat content, we've also done the word for heat content. Heat content is sometimes known as enthalpy. And you know that each system has a certain amount of heat, and the changes in heat occur during either a physical change or a chemical change. Now, this change in heat content, delta H, is the difference between heat content of the products minus heat content of the reactants. So that is the relationship between the enthalpy of products, the enthalpy of reactants, and the change in enthalpy. So basically, if the heat content of the products is higher than the heat content of the reactants, that means delta H is more than 0, or in other words, it's positive, then that means the reaction is endothermic. But if the heat content of the reactants is higher than the heat content of products, that means this value is definitely negative. So delta H is less than 0. That makes it an exothermic reaction. So these are the two things you need to remember about the value of enthalpy. You may have to calculate this, and then when you do calculate, you have to find out whether it's an endothermic reaction or an exothermic reaction. And that is all that we will be covering in this video. Thank you so much for watching this one, and don't forget to visit our website at perfect-scores.com, email us, and this is our Facebook address. Thank you for watching this video.